Okay, fine. So last video that we learned up to example number 20, 19. Okay. Now two examples is left to complete this chapter. So when statistic and chapter number 3, example number 20. Okay. So two examples is left. Let us start example number 20. Number 1. Again two examples is there. So out of this number 1, if the regression line is y cap is equal to 2x plus 5, 2 by x. So y cap is equal to x by 2 plus 5, and second information is xy z sx is equal to 5 z 8. Find the coefficient of determination. Coefficient of determination. It means that we have to find out the value of r square. Okay, fine. So to find out the value of r square, first of all, what we have to do? We have to find out the value of r. So now, first of all, we have to find out the value of r. Okay. So what do you mean by r? So r is equal to, we can say that b is given. So r is given to b into sy by sx. So this is the value of r, that is b into sy by sx. Okay. So here that we can say interchange. So in the value of b, that is r into sy by sx. Now whatever information that we have to put that information in particular value. First of all, y cap is equal to x by 2 plus 5. Here originally we can say that y cap is equal to a plus bx. So whatever only single digit is there, that we can say that it is a a. And with x, whatever information that we have, we can say it is a b. So here that we can say that x single digit, that is a is equal to 5, 1 by 2 into x. It is the same. Let's understand again. A plus bx. It means that whatever single digit is there, that we can say that it is a x. Sorry, it is a. So here x by 2 with x, that is bx. So it is a bx, and here only single one is there, denoted by a. So a is equal to 5 plus b is equal to, see here 1 by 2, that we can say into x. So what is the value of a? So here a is equal to 5, b is equal to 1 by 2, and this is the value of b. This the value of b that we have to use to find out r. Okay, so here 1 by 2 into r that we have to find. Now sy by sx, 5 and 8. So here this is the first working. Second working, that is as we discussed yesterday, sy sx is equal to 5 and 8. This information that we have to put in the division. Okay, so here sy by sx is equal to 5 by 8. Is equal to 5 by 8. Okay, so this information again that we have to use 5 by 8. Now r is equal to 5 by 8. Yes, 1 by 2, this interchange into this cross multiplication, 8 by 5. So 8 by 10, that is 0.8. This is the value of r. What we have to find out? R square. So we have to do the square of it. So r square is equal to 0.8 square, 0.64. So this is your answer. Again, how we can find out? Let's understand once again. Whatever the value of b, formula of b. So b is equal to r into sy by sx. This is the value. Now whatever information that we have to put that information in the formula. So here b is equal to 1 by 2. How we can get 1 by 2? This is the important point. Y cap is equal to x by 2 plus 5. So what is the original formula of y cap? Y cap is equal to a plus bx. So here whatever single digit is there, that we have to denote it as a, and with x with denoted with b. So here single digit is a, so a is equal to 5 plus x by 2. It means that here 1 by 2 with x. Okay, so because 1 into x is equal to x, so x by 2 same, there is no change. So here 1 by 2 into x. So what is the value of b? 1 by 2. This 1 by 2 that we have to use in this particular thing. Okay, so 1 by 2 into our sy by sx in zem proportions it is given, so we can change that particular thing, particular value into dividation 5 by 8. So here 5 by 8. Now our opposite side 1 by 2 opposite side. So here 1 by 2 into here this is change. So it is 8 by 5. 8 ones are 8, 5 twos are 10. So 8 by 10, that is 0.8. We have to find out the value of it, square of it. So how we can find out the square? 0.8 into 0.8, that is 0.64. Okay? So in this way, we can find out the value of r square. Okay? Now next, second one. So what is the second? Let's see. This is the second one. If the regression line y on x is, it means that 4x plus 5y minus 65 is equal to 0. So this information that we have. Find out the value of regression coefficient b. It means that we have to find out the value of b. It means that we have to find out the value of y. Y cap is equal to y. So 5y that we have to take right side, and 65 goes opposite side, and 4x. Because what we have to do? We have to change the sign. So when we change the sign, sign is changed. Okay. So here plus 5 by 5y and 65 it is minus, so converted to plus. 4x it is plus, goes opposite side, so it's a minus. Now is equal to, yes, so y is equal to 65 minus 4x divided by 5, because this 5 goes in division. Okay. Now what we have to do? Y is equal to 65 by 5 minus 4x by 5. Okay, we have to write separately. And now we have to solve. Y is equal to 65 divided by 5. That is 13. Yes. So this is the 13. So 13 minus 4x divided by 5. So 4 by 5. So 13 minus 0.8 into x. So this is the value of y. So y cap. Y is equal to y bar is equal to y cap, that we have to learn in the properties of regression. Okay. So what is the y cap? So y cap is equal to a plus bx. So we got the answer 13 minus 0.8 into x. So this is the value of. So what we have to find out? We have to got the value of b. So what is the value of b? Minus 0.8. So b is equal to minus 0.8. So this is the value of b. Again, how we can find out? First of all, whatever information is there, we have to find out the value of y. So separate y. So 5y is there, is equal to 65 minus 4x. Divided by 5, multiplication goes opposite side, so it's a division. Separate both the things, 65 by 5, 4x by 5. 65 by 5 is equal to 13. So 13 minus 4x by 5. 4 divided by 5, 0.8. 13 minus 0.8 into x. Now as we know the properties of y, properties of linear regression, y bar is equal to y is equal to y cap. So value is same. So y cap is equal to a plus px, 30 minus 0.8x. So here b is equal to minus 0.8. So in this way we can find out first example as well as second example. Okay. So let us start last example of this chapter, that is 21. So because before the start of this example, okay, that various properties of regression is there that I will do right, because this property that which is used. Okay, so here u is equal to x minus a, v is equal to y minus b, and that's why we can say that d by x is equal to d v u, because value same. As we know, the property of regression, only data is changed, okay, but their concept is not changed. Second one, that if u is equal to x minus a upon cx, v is equal to y minus b upon cy, then we can say that byx is equal to buv into cy by cx. These two properties already that we learned and already used in particular example. See, this 21 example is so easy. Only we have to prove that value is changed or not. Okay, so it is so easy. When I calculate, you can see. Okay, so number one, for example is there. Out of that, number one, what is that? That byx is equal to 0.85. U is equal to x minus 15. V is equal to y minus 20. Then we have to find out the value of b, v, u. So as we know, the first property, b by x is equal to b, v, u. So here b by x is equal to 0.85. So value of b, v, u is also same, that is 0.85. Okay, so here there is no change in value. Okay, here only we have to prove that there is no calculation. Next, number 2. So let's see what is number 2. Number 2, u is equal to x minus 5 divided by 3. Okay, so here u is equal to x minus 5 divided by 3. V is equal to y minus 8 divided by 5. And byx is equal to 0.9. So we have to find out the value b, v, u that we have to find out. Okay, so second property is used here. U is equal to x minus a upon cx, v is equal to y minus b upon cy. If byx is equal to bv u into cy by cx. So same property that we have to use here. So we can determine these things, that is byx is equal to bvu into cy by cx. So value of byx is equal to 0.9. So value of bvu is also 0.9. So there is no change in the value, because as we know, when we learn u and v in property that we can learn, in theoretical part that we can learn, only numbers is changed. There is no change of concept, and that's why this is helpful. Now number 3. So third one is that, what is third one? If u is equal to 10 minus x into 4.5, v is equal to y minus 50 divided by 10. So here dyx is equal to 0.25 bvu that we have to find. Okay, in this example again same, because when we use, that is because this 10 is there, those one into division. Okay, so it is 1 by 10. So here, and as we know that v is equal to y minus 50 divided by 10. So again dyx is equal to 0.25, dvu is equal to again 0.25. So there is no change because same property that we have to use. Okay, and for that we have to find the value of b. So how we can find out? So b is equal to dyx into cx by cy. Okay, so 0.25 into 1 by 10 divided by 10 is equal to 1 by 1000. Sorry, 0 into 0.25, so 0.0025, because we have to put the value. We have to put the value, whatever value is there, because x minus 4.5 into 1 by 10. So here same thing, 0.25, that is value of dyx into 1 by 10 divided by 10. 10 into 10, 100. So 1 by 100 into 0.25. Okay, so 1 by 100, 0.25. So in this way, we can find out the value of 0.0025. Same as number 4. So fourth example is also there. So fourth example, u is equal to 5 minus x minus 14. V is equal to 2 into y minus 18. Okay, if dyx is equal to 1.6, we have to find out dvu. Okay, so here also same x, dyx is equal to dvu into cy by cx. Okay, so put the value 1.6 into 1 by 5, because this 5 goes down, so 1 by 5 divided by 1 by 2. This 2 is again goes down, numerator to denominator. Okay, so here 1 by 6 into 2 by 5. Numerator goes into denominator. Okay, so 1 by 1 into 1.6 into 2 by 5. So 1.6 into 2 by 5. So here that we can say that 1.6 into 1.6, that is 3. Okay, directly we can do 1.6 into 2 divided by 5. So with the help of calculator, that you can find out it's 0.64. Okay, so in this way, it's very short example, only two principles, that first and second, two principles that we have to use, and this already we have to use in long examples. Okay, so this is all about example number 21. In this way, all the examples that today we have completed, but one theoretical portion is left, and that portion is precautions while using regression. When we are using regression, what are the precautions that we have to take care? Okay, so page number 148 is given. We know that regression is the functional relation between two correlated variables, and hence we can estimate the value of dependent variable from it. Okay, so as we know, if value of one variable is given, we can find out the value of another variable. The regression analysis is very useful in the decision making in the practical field like economics, trade, industry, education, psychology, sociology, medicine, planning, etc. So in all the fields, that regression is taking helpful to take the various types of decision making. Next one, in spite of vast application of regression analysis, some precautions are be necessary to using it. Number one, the reliability of the estimate can be verified by the coefficient of determination r square. So because before the use of that regression, first of all you have to check it the reliability. Okay, determination r square, that it is reliable in nature or not. So we should use the estimate only after the ascertaining the linearity of the regression by the coefficient of determination. So first of all, whatever information that we have to take and we have to use, before the use of that particular thing, what we have to do? First of all, we have to check the reliability. It means that we have to find out R square, that it is reliable or not. Next, number 2, another point which is necessary to keep in mind while using the regression analysis is the regression relation obtained by the scatter diagram or by the method of least square should not be used for the value which are very far from the given value of the independent variable. So here, if that you already learned that on the depend on that particular data that we have to select, that which method that we have to use to find out regression. It is a scatter diagram method or least square method. Okay. Next one, example, if for some data there are high degree of correlation between the rainfall and yield of wheat, we can say rainfall increases, yield of wheat also increases. Now using the regression relation obtained from given data, if for the some value of rainfall corresponding yield of wheat is to be estimated, when the estimate of yield for wheat can be proper only when the value of rainfall is around the given value of rainfall. So as we know that if one value is given, then we have to find out the estimated value of another. So before the using of it, first of all we have to check it whether it is useful or not. And last, that if there are heavy rain, the crop may be get damaged and the yield of wheat may also decrease. In such case, the dependent variable yield estimated from the above mentioned regression relation may be wrong. Okay, that is the good example. That if we are understand that rain is increases, yield of wheat is also increases. But in practical manner, that is happening. If yield of rain is too high, it may be possible that yield of wheat is damaged. So it's a negative. So always it is not that if one is increases or one thing is positive, second is also positive. First of all, we have to check it whether it is proper or not. Okay. So this is the precautions by using the regression line. So this is the end of chapter number 3. Okay. Thank you.